Yes, hope all of us are doing great. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. So, in our discussion today, we're going to look at the relationship between a classical adjoint, a determinant, and an identity. And of course, this is going to give us a reference of finding each of the specific aspects which I've mentioned about. Now, this is going to stem from a relationship whereby we're going to have this relationship given as if we have a matrix A given in terms of A, B, C, and D, basically give it in this specific order. So if we have a matrix which is a 2 by 2 matrix given using those specific letters for A, B, C, and D, we can define, so these are specific elements of this matrix which is a square 2 by 2 matrix. We can define that matrix or given as the product of that matrix and the classical adjoint is going to give us what we refer to as the determinant of that matrix multiplied by identity. So in this case, I'm going to explore the relationship which exists between this matrix, its classical adjoint, determinant, and identity. And of course, by doing a simple evaluation, which is going to create a basis for us finding these specific elements. Now, in this case, we have defined the concept of identity of a matrix as a product between a matrix and the inverse of a matrix. And this basically given us the element of identity. Now, this is one of the, of course, characteristics of an inverse which we have defined. That basically, if we have an inverse of a matrix, then that matrix we are going to obtain this aspect of identity. Then, therefore, we can do a manipulation of this specific aspect and try to find what basically the relationship between this one. Now, having defined identity, we can do a substitution for this one using this specific first aspect. Therefore, by defining the product between a matrix and the classical adjoint given in terms of the determinant of that matrix, and therefore we're going to have this aspect of identity being given in terms of the matrix A and the inverse of the matrix A. So for us to come up with this specific inverse as a subject, we're going to define this one by the matrix and of course the determinant of that matrix on both sides, and therefore have this determinant times A given as such. So we are therefore going to cancel these respective factors which are appearing on the numerator and the denominator. Now on my right side, I'm going to remain with this specific inverse, and in this case I'm going to cancel A with this. So therefore on my left side I'm going to remain with the 1 over the determinant of that matrix times the classical adjoint is equivalent to the inverse of that matrix given in that specific case. Therefore I can define the inverse of a matrix as the product between 1 over the determinant times the classical adjoint given in that specific respect. Therefore, from that one, that's going to give us a general formula of finding our determinant given the general matrix of A, whereby we're going to see that generally, then therefore, we can have the inverse of our matrix A, B, C, D, given in terms of 1 all over A. So this is going to be AD minus CD, which basically is going to form our determinant, and then we're going to have the adjoint of that one given in terms of B, A minus B minus C given as such. So later we're going to see that the specific aspect of this particular determinant, this second part, is going to be a transpose of the matrix of the cofactors. And of course, that one we're going to look at it in a specific video whereby we're going to give a specific example. Now, in this case, I assume that we have, of course, understood the relationship between a classical adjoint, a determinant, in this specific case, and the element of identity. And this, of course, together are going to assist us come up with a general formula of finding especially the inverse of a matrix, having explored the relationship which exists between the various elements of this specific topic under discussion, as I've said. So that is it for now, guys. By God bless you. Catch us in our next video.